This one was the questions 16 that is on the study guide of the chapter 24. Let's go to solve this question again because I made a mistake when I solved it during class. It's a energy density, but is first of all I didn't realize at the beginning that is asking about the density, that energy density is not asking about the energy, the potential energy, is asking about the energy by the density of energy. So it's say like this, it's you have a capacitors with round plates, so capacitors with round plates. When you double the radius, the area, pi r square, pi r0 square, if you double the initial radius, the area, the new area will be pi by 2 times r0. You double the r0 square, so you will have 4 times pi r0 square, so it will be 4 times a0. Okay. This is what I did before. The radius and the distance d, you double also. So from the d0, you go to a new distance that is 2 times d0. So it's saying what happens with the density of energy will change. I thought at the beginning that it will not change. My idea that was reasonable why it will not change is because the charge will not change, the electrical field will not change. So if the electrical field will not change, the density of energy, is 1/2 x naught 0 E squared. Well, if the electrical field doesn't change, the density of energy will not change. But indeed, I made a big mistake here, because when I create 4 areas for the parallel plates, 4 areas, the density of charge now is the original density divided by 4. So now the electrical field is changing, because the electrical field between the 2 plates is the density of air. The electrical field is the density of charge divided by x naught 0. This is E0. But now if I double the radius, I quadruple the area, and the density of charge is diminished by a factor of 4. So you see here I have the same quantity of charge because I have sigma 0 divided by 4 multiplied by 4 times the area A0. This is the area A0. So I have 4 times A0 here. So I have the same charge. But the electrical field, it changed. It changed by a factor. The new E will be the same, the density of charge divided by 4, the density, the superficial density divided by x naught 0. So the new E will be 1/4 of sigma 0 divided by x naught 0. Okay, this is the new E. So I can do the problems now, taking in account that the electrical field will change to 1/4 of E0. I can make the problem in several ways. Well, the first way is to find the initial U0. Initial U0 is 1/2 Q0 by V0. Okay. And the final U final will be 1/2 Q final, that is Q0, haven't changed, by V0, by the new V, by the new V. The new V is the new E by the new distance D. But the new E is E0 divided by 4. And the new distant D is 2 times D. So the new 2 times D0. So it would be E0 multiplied by D0 divided by 2. So the U final will be 1/2 the Q0 that have not changed by the new B, but the new B is 1/2 E0 by D0. So the U final is 1/2 of 1/2 Q0 by E0 by D by V0. It would be 1/2 of U0. But they ask about the density of energy. The rho zero initial, the density of energy initial is U0 divided by the volume. The volume is A0 by D0. And the density final, when I make the double the radius and double the distance D, it will be U final. U final is 1/2 U0 divided by the new volumes. But the new volume is 4 times A0 multiplied by the distance D0. Distance D0 is 2 times D0. So it will be 1/16 of U0. And I found the answer. This is the correct answer. The other way to visualize this is that the density of energy, rho zero, is 1/2 epsilon 0 by E0 squared. Okay, this is the density. What will be the rho final? The rho final will be 1/2 epsilon 0 by the new electrical field, but the new electrical field is E0 divided by 4, because I have told you that if I split the charge between 4 times the initial area, A0, the electrical field will be weaker square. So it will be 1/16 A0, 1/416, yes, 1/2 of 1/16 A0 by E0 squared. So it will be 1/16 of 1/2 epsilon 0 E0 squared. But this amount is 1/16 of rho 0. So the rho final, the density of energy, is changing by this factor. So this is the correct answer for this problem. Sorry, I didn't write here correctly. This is the U0, U0, A0, and the D0, this is rho 0, okay? And the 4 by 2 is 8, with 1/2, 8 by 2, 16, 1/16 of rho 0. Sorry, I didn't write it correctly. So rho 0 is this amount, okay? So rho final, so I made the same problem in two different ways, okay? So at the end, the density changed by a factor of 16. You dilute the density of energy. It's like diluting, like spreading the electrical field in more volumes. So you spread the electrical field, the existence of the electrical field during a bigger volume. So you change the density. You change the density of energy.